Bright Tuty. Every student matters.
The potential energy of a freely falling object decreases progressively. Does this violate the law of conservation of energy? Why? First of all, once again, let us remind ourselves what is law of conservation of energy. The law of conservation of energy states that energy can neither be created nor be destroyed. It can only be converted from one form into another. Right? Second thing, we have studied while we were doing law of conservation of energy, we have studied the case of energy transformation in a free falling object. In that case, we have seen that if this is the ground level, if this is an object thrown from certain height, at this height it was having potential energy and there was no kinetic energy. But when we allow it to fall, then the potential energy decreases, but since there is a increase in the velocity of this object, so we say that kinetic energy is getting increased. So by the time this object hits the ground, whole of the potential energy is getting converted into kinetic energy. And since the energy transformation is taking place, the potential energy is converted into kinetic energy. Therefore, we will say that there is no violation of law of conservation of energy. It is satisfying the law of conservation of energy. Right? Let us see the next question. What are the various energy transformations that occur when you are riding a bicycle? Now, when you are riding a bicycle, what you are doing is you are pedaling, and when you are pedaling, you are consuming your muscular energy that you have in your body due to the chemical energy of the food. This muscular energy on paddling is getting converted into the kinetic energy of the bicycle. Why? Because the bicycle is moving in the forward direction due to your paddling. So, when we ride a bicycle, we are converting the muscular energy of our body into the kinetic energy of the bicycle. Got it? Now, let us see the next question. Does the transformation of energy take place when you push a huge rock with all your might and fail to move? Now, we know that work done is equal to F into S. So, we are applying a lot of force, no doubt, but since there is no displacement in the rock, so we will say that we have not done any work. The work done will be zero, but there must be some transfer of energy. Why? Because I am spending my muscular energy. I am spending a lot of my muscular energy in pushing that huge rock. And since law of conservation of energy states that energy cannot be destroyed, so the energy which I have spent, right, pushing that rock cannot go wasted. So where has it transformed into? It has transformed into number one, the potential energy of the rock. Right, some of the energy will be just stored in that rock in the form of potential energy, and some of the energy will get spent in the environment, right, due to the surface of my hands rock and the rock and the ground, right. So, my muscular energy will get wasted in the environment, and a bit of it, some amount of my muscular energy will be stored in the rock in the form of potential energy, right. Let us see the next question. Illustrate the law of conservation of energy by discussing the energy changes which occur when we draw a pendulum bob to one side and allow it to oscillate. Why does the bob eventually come to rest? What happens to its energy eventually? Is it a violation of the law of conservation of energy? So, many questions are being asked. First of all, we will try to relate. This we have already done when we have taken up the topic law of conservation of energy. Let us do it once again if you have not seen it there. Now, a simple pendulum means we have just taken a bob and attached it with a rope which is further attached to a particular point, and this is basically free to move. Now, the resting position is known as the mean position. If we take it to a particular height, let us take this is the height that we are taking this bob to, and let us say that this is the position, the maximum height it has received. So, this is known as extreme position. When we drop the bob or the pendulum from here, it will go like this, and then it will move on the other side to a particular level. Let it be that level. This is also known as extreme position. Now, at this extreme position, because of the height, this particular bob is having potential energy, only potential energy, right? When it is allowed to fall, then from position, let us give these positions ABC names. From position A to B, this bob is having some height as well as some motion. Therefore, here we will find that the bob has potential energy as well as kinetic energy. The moment it reaches this position B, the mean position, at this position the height is 0. So, this bob is having only and only kinetic energy, no potential energy. Now, when it starts moving going up, then in that case, now again it will have kinetic energy as well as potential energy, because it is achieving some height as well as motion. At this point C, the extreme position, again at this point the bob is going to stop for a fraction of a second. Here again this will have only potential energy, no kinetic energy. So, this is the energy transformation which take place. Now, the second part of the question is, why does the bob eventually come to rest, and what happens to its energy eventually? Now, when the bob is oscillating in to and fro motion, there is some air resistance also acting on it, and because of that air resistance, the air resistance is always opposing its motion, and because of that some of its energy is getting lost into the atmosphere, because of which eventually it will come to rest, right? So, the energy is not getting destroyed or damaged somewhere, it is just getting converted. That is why it is not a violation of the law of conservation of energy. So, this is the energy transformation taking place in case of a simple pendulum. I hope this is clear to you. A free falling object eventually stops on reaching the ground. What happens to its kinetic energy? Now, till now, we have seen that a ball or an object was dropped and it was falling freely. This object was having potential energy, and when the object was dropped, slowly and slowly it gains some velocity, and by the time it reached the ground, just before touching the ground, because the height being 0, the potential energy will get 0 and whole of the potential energy gets converted into kinetic energy. But now the question that is being asked from us is just one step ahead. The moment it strikes the ground, it eventually stops, right? It is not bouncing back or something, it stops. So, when it stops, then we say that the kinetic energy is also 0. The potential was in fact 0. So, where did this particular energy go? First thing, the moment it strikes the surface, there will be some sound produced. So, this kinetic energy is getting converted into sound energy. Whenever an object is dropped from a height, the moment it strikes the ground, it will produce some sound. That is also a form of energy. Secondly, if you feel the surface, you will find that even though it is very small, but there will be some heat energy also produced, because whenever two objects come in contact with each other, because of friction, heat is produced. And the third important thing is, if it is not bouncing back, therefore there must be some potential energy. And now this potential energy is not actually gravitational potential energy. It is not because of its height, but if you will see, there will be some deformity or change in shape of this object. And because of that change in shape, we will get now elastic potential energy. We have studied about elastic and gravitational, if you remember. So that will be elastic. So if a freely falling object eventually stops on reaching the ground, the kinetic energy of that object will be converted in either of these forms of energy or all of them to a smaller extent. Got it? So these are a few back exercises question, and this is all about our work and energy. I hope you have understood the chapter. Please revise the chapter again. Please try to relate all the formulae used. We have used work done, we have used the formula for energy, whether it is kinetic or potential. Then we have talked about the electrical energy consumed. So please try to relate all these formulae, and please try to do all the numericals with your own hand to get a good command over these. And while doing the numericals, please make sure to see and observe the units. Most of the times I have found that the students, they lose marks just because they do not take care of the units. No matter how well you know the formula, but if you have not converted the units, then in that case the answer is not right and you will be not granted marks into it. I hope you have understood it all. Thank you so much.